Good morning and welcome to this first session after our keynote. And we are kind of continuing in the theme of space, as you see on the slides from Katie. But a few words about Katie herself. Katie is a polyglot programmer with a penchant for functional programming, as some of you may already know. But if you followed the Twitter feed, you also know that today she's not going to talk about functional programming, but about something else, because she has a lot of different interests. And while working at Red Hat, she is involved in the OpenShift project and has co-authored a book called Getting Started with OpenShift. She also founded the Lambda Ladies Group for Women in Functional Programming and co-organizes the Brisbane Functional Programming Group. If you want to know about more of that or any other things that she's involved in, please see her after the presentation. Now over to you, Katie.
Thank you. Yeah, so good morning, everyone. My name is Katie, and you'll find me under Code Miller, normally on the internet. There's about the three topics that I really want to touch on today. The first of those is spatial, so how we can make applications that make use of data that has a geographical or geospatial component. The second area is cloud, more specifically platform as a service. And lastly, I want to talk a little bit about application scaling. This session, though, I should mention, is not going to be a deep dive into geospatial analysis. It's really just the basics, enough to get you started and possibly make you dangerous. To start off with, though, I want to find out a little bit more about you. So, who uses Python? Excellent, you're awake. Who's familiar with the command line? Say, comfortable using the command line? Most people, excellent. We're going to be doing a little bit of that today. Who uses MongoDB? Give me some idea. Okay, only a smattering. Okay, so the demo app I'm going to be showing you today does use Mongo, so you're going to be seeing a little bit of that. And finally, who would say that they could define the term platform as a service? Who knows what PaaS is? Okay, a few, but not most. So hopefully by the end of this presentation, you'll have a much better idea of what platform as a service is. So yeah, due to the time constraints today, as Christina has mentioned, if you could please hold your questions to the end. I've got a few goodies to give away to people who ask questions, so I'll be hanging around the swag booth out there, copies of the book and a few of these cool Code On t-shirts. So come see me afterwards for that. So to make a mapping application, we need some data to map. So I went out and had a look around for some data sets for Wellington, and I found a data set for public conveniences, which, in case it's not immediately obvious, as it wasn't to me, is a very kind of polite British way of saying public toilets. I'm not sure why they couldn't have just said toilets, but it's government data. I guess saying things plainly is not their specialty. So the use case for the demo app today is when you're out and about and you want to find a toilet facility in Wellington. And yeah, if you've got pets at home like this, turning your private conveniences into inconveniences, it may well be something that you want to do. So the demo app looks like this. So it's called Convenience Finder, and you can move around the map of Wellington, zoom in and out if you like, and click on your facilities to find out a little bit more about them. So simple little mapping app, making use of all open components. So using open source code, open data from the council, and it's also hosted on an open cloud platform. So I mentioned I'm going to be talking a little bit about scaling. So when you're making applications, this is something that you want to have a bit of a think about. You can imagine if your application becomes really popular overnight, it might be something you have to deal with. So for our demo app, we can imagine maybe there's a gastro outbreak or something, and all of a sudden, everyone is hitting the site. You want your site to be able to deal with that. So in order to demonstrate that, I'm going to start hitting that application with some load now using a little tool called BlazeMeter. So we're going to get a test running with 1,000 users doing you can't see there, an extreme stress test, hitting a number of endpoints. And so hopefully we can come back later in the presentation and see that that application has been scaling to meet that demand. And there's a few different ways that we can see that. There's a HA proxy status page that we'll be able to look at. Don't worry about any of this other than the fact that there's one green bar there, which means we've got one container that's serving up the code. Another way we're going to be able to see that is here on this page. We can see that we've got 2 containers started. So we're going to see hopefully some more of those going on. And there's another way on the command line, which I'll show you later on. So onto the first one of the areas I want to talk about, which is spatial. Can anyone tell me what shape the Earth is? Anyone? Oh, got a few different things. Yeah, I guess it's not a sphere, right? It's an ellipsoid. It's a flattened sphere. And this is something that we have to worry about when we're making spatial applications. The Earth is not a perfect sphere, and we have to take that into account. So there's a little bit of terminology. I'm going to quickly go over first things that we need to be aware of. So the first one of those is datum. So this is a model of the Earth that's used for mapping. So a series of numbers that define the size and shape of the ellipsoid called Earth that we're talking about, and where it is in space, its orientation in space. And there are different datums that you might use for different situations. So some datums provide a really a best fit model for the entire Earth. But you can imagine that if you're making a map for one very specific place on Earth, perhaps a model that works really well for the whole Earth might actually be poor for that particular area. So you might use a datum that's optimized for that particular area of the world. So when you're talking about latitude and longitude, this always needs to be specified in terms of a datum. The second term we need to be aware of is projection. So we know the Earth is three-dimensional, maps are flat. When you take something three-dimensional and flatten it out, that process is called projection. And no matter how you try, there are some trade-offs that you have to make, some distortions that happen when you do this. So things like area and the accuracy of distance between things and direction and this kind of thing are things that need to be decided how you're going to do that when you make this projection. So a datum plus a projection plus some kind of unit of distance gives you a coordinate reference system. So the takeaway from all of that, if it all sounds like gobbledygook, is basically if you're making a mapping app and you've got things coming up not where you expect on your map, it's probably because you've got some kind of issue with your datum or projection. So other things we need to be aware of is our data and how it's formatted. So the data I'm using today is WGS, or World Geodetic System 84 data, and that's the standard number for it. So this is a common standard. It's actually the one that's used for GPS. So this defines a datum and a projection and a coordinate reference system for the Earth that you'll very commonly find. So when you go off to find some data to map, if you're going to make a version of the demo app that I've shown, then these are the numbers that you're going to want to look for. Another thing we want to know about is shapefiles. So this is a very popular geospatial vector data format. And the name is a bit of a misnomer. It's actually multiple files. There has to be at least 3 of them. But this is, again, something when you go off to find your data, you'll often find that shapefile is one of the formats you're able to download it in. And that was the case for the data set that I'm using for the demo app today. However, when you actually come to use it, you may well want to use something else, and this is another popular format, GeoJSON, so using JavaScript object notation, which no doubt all of you are very familiar with, to describe the geodata as well as other features, other related features, as we'll see when we have a look at some data a bit later on. But I mentioned that you might download something as a shapefile, so how do you turn it into GeoJSON? So one way you can do that is with a very popular open source library called the GDAL, or the Geospatial Data Abstraction Library. So you can get that on your machine, and that will give you this tool, OGR to OGR, which you can use to turn shapefile into GeoJSON. So where do you find data? There's a bunch of places. So government data is a good way to start. So there's sites there for New Zealand and Australia. New Zealanders obviously don't trust the government because there's also an open data catalogue of the same data that you can get on the government site. And then there's a bunch of others. So Coordinates, which I noticed is a sponsor here, is actually where I found the data I'm using today, and a few other links there. And these slides will be available, so you can go check out these links later if you like. So what's actually in this demo app that I've showed you? So on the back end, we've got Flask, so a very lightweight Python micro framework that I'm sure you're all pretty familiar with, so I won't waste too much time talking about that. On the front end, we're using a library called Leaflet.js, which is a great little client-side library to get started with mapping applications. It works well on mobile, out of the box works with OpenStreetMap and a bunch of other things, and has a great library of plugins. So it's really a nice entry point to getting started with making some mapping applications. And as I've already mentioned, I'm using the MongoDB database. So for those who aren't too familiar with it, this is a NoSQL database. It's schemaless. The data is stored as documents, so collections of attributes and values in a JSON-like format. and so your data can be nested, and so named Mongo from the word humongous, so it's able to deal with many requests by using replication and horizontal scaling. So why Mongo? So Mongo is a good entry point because it has some nice support for some spatial things. So it handles GeoJSON, the format I mentioned earlier, natively as of Mongo 2.4. It has the support for doing indices of both 2D, so flat stuff, and 2D sphere, so when you're talking about an Earth-like sphere, indices, and so that's the kind of index I'm using in the demo app I've shown. And it also has support for a number of different geospatial queries. So we're able to do proximity queries, so what things are near this thing, inclusion, so given some polygon, what things are within that, and where things intersect. And so the last kind of piece of the puzzle is platform as a service. So as not everyone was kind of aware what it is, so I'll start by just giving you a bit of a rundown of what this platform as a service thing is. So I've got 3 different cloud computing services mentioned here. So we've got infrastructure, platform, and software. And so you can see over to the left, a lot more things are managed by you, the things in blue, so you get more control. And as you go over to the right, everything's suddenly all purple, so this is managed by your provider, so you get more automation. So platform as a service sitting in the middle. So kind of quintessential example of infrastructure as a service would be something like Amazon EC2. So when you go there, you have to pick what operating system you want, you have to keep it up to date yourself, you have to install your app server, your middleware, all of these things are managed by you. On the other end of the spectrum, with software as a service, say something like Gmail, as a developer, there's nothing really for you to do there, you just use it. Platform as a service is sitting in the middle, so you still have to write the code, but things like your application server are already configured for you, and your operating system is something you don't even really need to worry about. So all these other things in the stack that are pre-configured, you can go in and tweak them if you need to, but out of the box, things will just work, so you can focus on the code. So it's basically cutting out a whole bunch of steps that could otherwise be in this process. And I guess we all know often things aren't quite so simple. Often it's code, put in a request for some servers, wait for them to be racked and stacked, bug a sysadmin for a while, wait for them to install what you need, etc., etc., etc. Like it's not quite so simple. So your platform as a service is trying to cut out a bunch of that sort of thing so you can self-provision and get things up and running quickly. So benefits of that enables us as developers to focus on code rather than configuration, which is what most of us tend to prefer. Enables you to deploy quickly and easy, so do things like your continuous deployment. It's very convenient, so with a lot of platform as a service, deployment is as simple as a git push. And more efficient, so PaaSes are able to run many applications on one server, so making the best use of resources. Scalability, as I've already kind of mentioned, is something that can be managed for you by your application platform. And lastly, a lot of PaaSes give you the ability to experiment with different stacks. So it's rare for a PaaS to just focus on one single stack, so you as a dev are able to spin up something else that's all ready to go for you and experiment with that. So if one day you want to try something other than Python, that possibility is open to you. So Red Hat has an open source platform as a service, and it is called OpenShift. And the word OpenShift, though, actually refers to 3 different things, confusingly. So we've got OpenShift Origin, so this is the open source project. It's on GitHub, Apache 2 licensed, currently written in Ruby, although OpenShift v3 is going to be written in Go because we're moving to a Docker-based model. This open source project feeds into 2 other projects. So on the left here, we've got OpenShift Online. So this is a public cloud service that you'll find at openshift.com. It has a free tier, so you can go there and get 3 containers running in the cloud to run your app for free. And there's about, I think, 2 million applications now that have been deployed on that. And then on the other side, you've got OpenShift Enterprise. So this when big companies want to run a PaaS on-premise or perhaps some kind of hybrid model, they're able to use a stable, supported version. So architecturally, this is one way we can picture it. So OpenShift is based on Red Hat Enterprise Linux, so you can also run it on other RHEL-flavoured Linuxes. So it can run wherever RHEL can run, bare metal, in a VM, whatever it is that you want. We have a broker that manages the orchestration of a number of nodes. And then on these nodes, you have containers, which we refer to as gears, in which your application actually runs. And the containerization here is done with SE Linux and C groups to manage the resource allocation. And obviously, it's all very well to have a container, but you want that container to have some capabilities. So what this is showing is that you can have what we call cartridges, so these puzzle pieces that you plug in of things that you might want to use. So for you guys, Python, databases, so MySQL, Postgres, Mongo, and other things like cron and Git, and that are all provided as well. There are a number of different ways to interact with it. There's some IDE integration and there's a REST API if that's how you roll. But the two main ways that people tend to use are the web console and the command line, which is what I'll be showing today. And so the last area I want to touch on before jumping into a demo is scaling. So as we know, there are two different types of scaling we can do. We've got vertical scaling, so as our load ramps up, we throw more and more resources at the problem. So that's illustrated by a big bug on the left. So more RAM, more CPU, more disk, whatever it might be. The other approach, horizontal scaling. So as our load ramps up, instead we throw more commodities, ants, whatever, things that we don't care about so much if they die at the problem, and deal with the load that way. So on OpenShift, it looks like this. OpenShift does scaling automatically out of the box using HA proxy. And you can customize how it works, but out of the box, it's based on the number of concurrent connections. So when that reaches 90%, it'll automatically scale up another copy of your application. So here shown, it's got 3 copies of the application, and HA proxy will load balance between them. And out of the box, using the least connection algorithm, but again, it's all open source, it can be configured. And then you've got your data tier at the back. Right, so that's enough of the slides. Let's jump in and have a look at the demo. But actually, before I get to that, let's see how this app is handling it. So if I go to the reporting page, this little bit relies on the internet, so hopefully it works. Okay, so see the responses went right up, and the response times are kind of going up and down, which is what normally tends to happen as we scale up and down. So if we reload this, at the moment, okay, so this is telling us at the moment we've got now 2 containers serving it, and there's a third one that's either in the process of going up or going down when I hit that right now. And if I refresh this, so this is the OpenShift web console for OpenShift Online. You can see we've now got 4 gears that are serving the code. So the app in total is using 5 gears. And I haven't actually set a limit on this, so this could go all the way up to 50 potentially, but you can limit these things, of course. So if we move over to the command line now, another way we can look at that is using the RHC command line tool. This is a Ruby gem. Oh, that looks terrible wrapped. Oh, that doesn't help. But that's again showing us how many gears we've got started and where they are and what their UIDs are. So how do we use RHC? So if you install the gem, so it's just a Ruby gem, sorry, you need to install Ruby. And install RHC, you do an RHC setup. This will ask you what server you want to talk to. I'm just using OpenShift Online, so I'm using the default. And then get you to sign in using your account. And it will also upload an SSH key for you and make one if you don't have one so that you can talk to it. After that, it's just up to you to make an application. So here are some of the cartridges that are available just out of the box. You've got things like JBoss and for you guys, notably Python 2.6, 2.7 and 3.3. These aren't all the things that are available though, these are the Red Hat supported ones. So you can also just put a URL in and access any of the community cartridges, and there are hundreds of those. Anything you can think of that you want to run, someone's probably already made a cartridge for it. So then to actually create your application, do the command RHC app create. You give the application a name, so calling it conveniences. You say what cartridges you want it to have. So I'm going to use Python 2.7 and MongoDB 2. And then you can also add some code of where you want it to grab the initial Git repository it's going to start off with. So I've already created this application. It's available on Git. And if we do that, and I've pre-recorded, I'm also selecting the size of the gear that I want, and the -S is for scalable. So that's it. To make it a scale application, automatically you just add -s. Because the network isn't so great here, I have pre-recorded this, so this will go a little bit faster than it might ordinarily. But you can see a few things happen there. So it created a Mongo database. It's given us some credentials for that, and there's a connection string there we can use to access it, so just stored in environment variables. It's set up the DNS. And so at the end of that process, and it also has cloned the Git repository. So it's created a container in the cloud, created the Git repo on there, and then cloned down a copy to our local machine. So we're now able to SSH that. The URL is live on the web at the end of that process, and we can go in and actually have a look at the code that's been cloned down. So if I do an ls on this, you can see some of the things that are in there. So this is the bits and pieces from the Git repository I was pointing to, but also this .OpenShift directory. And all cartridges have this. This is where the OpenShift specific config is stored. So if we have a look in there, you can see what you get. So there's a cron cartridge you can use for OpenShift, so there's a cron directory there if you want to add cron jobs. There's markers, so inside there I have a marker for hot deployment, so that when I deploy my code, the server doesn't actually restart, which is good, especially when you're doing development, you want things to go quickly. And also action hooks, so this is where you can put scripts when you want to hook in to the life cycle of the application, if you want to have something happen every time it deploys or builds or whatnot. So here is the data that I converted using OGR to OGR, as I mentioned. So you can see we've got, importantly in red, the coordinates and also some other information about the facility that was in the data that I downloaded. So things like the opening hours and whatnot. And I'm not going to have time to step through all the code because I have limited time today, but one thing I do want to quickly show is how we can actually make a change to this. So this is the main index.html. If I just scroll down, got a bunch of things in here, which probably look terrible in the large font size wrapped. So here we've got the actual JavaScript that's running in the browser. So we're grabbing some pins and putting them on the map. And when we do that, one of the things we can set is the icon. So I've had a friend who actually made an alternative icon for me. So with that change made, in order to push that live, it's a matter of just using your standard get commands. So add it, add some kind of commit message, and then do a git push. And out of the box, that will actually deploy the code live. Again, this is all things that can be configured. You can push without deploying if you wish. You probably didn't catch it, but it did say that, it's at the bottom too, that because I've got the hot deployment enabled, it didn't actually restart the server. But at the end of that process, the code is live, and we get something that looks like this. So this is thanks to my friend Ben, who made this wonderful little icon, which I think is very appropriate. So other things we can do, so if with RHC you can have a look, so you can control your app that way. There's a whole bunch of other commands, so things like SSH and SCP, things for managing teams, apps in different regions, your domains, things like adding an alias, so you want to run your app with a custom domain, you can use the alias there, and just management things. Port forwarding actually is a pretty good one. If I wanted to connect to my MongoDB database locally, you can use the port forward command to very easily get that set up and good to go. And things for backing up and whatnot. There's a whole bunch of different commands to explore. The one I'll very quickly show, because it's something that not every PaaS has the ability to do, is SSH. So you can SSH in there and have a look around. So this is what's actually on the gear. So we've got directories for the different cartridges that we've got. We've got app deployments, so this is where it keeps a history of deployments if you enable that feature, so that you can quickly roll back if you so choose. And then the app root, which is where I've actually got the repository, and each time you push your code, it does the rebuild. The thing probably most of note there is that inside app root there is a /data directory where you have write access. So although when you're designing scalable applications, normally you want things to be pretty stateless, if you do want to do something where you need write access on the gear, you have the ability to do that by using this /data directory. And you also have write access in /temp, which again, thanks to SE Linux, is private to you. And another thing you can do on here is access Mongo if you didn't have Mongo installed locally and didn't want to do the port forwarding. So we can jump in here and play around and have a look at our Mongo. So on the last thing, quickly show the gears again. So yeah, You can see we've got just 2 instances for this one running. And last command, there's also the ability to limit the scaling. So I could have done this in the web console too, but if I wanted to manually force it to scale up or down, I can set the range of how many containers I actually want serving that application at any one time. And yeah, put a max on it so it doesn't just forever keep going up. So let's have a quick look and see how our application is going. It's still being hit by load. Whoa, okay. So it's up to 5 gears now, one of which is Mongo, so 4 other ones. But still managing. I mean, feel free to hit that at the same time if you like. There's the URL, conveniences-cloudcraft.rhcloud.com. If you want to try it out and see how it's going under load. If we have a look at HA proxy, you can see, yep, confirm that that's what's going on. So I guess the nice thing of that is just having it all managed for you. I didn't have to do anything, 1-line command, pushed it live, all of a sudden my app's being hit by all this load and it's being managed. So to quickly sum up, what have we seen? So talked a little bit about spatial, datums and projection. Takeaway from that, if things are coming up at the wrong place of the map, I'll make sure you check what datum and projection it is that you're using. Talked a little bit about cloud, specifically platform as a service and the benefits of that, and a little bit about OpenShift and how that can manage application scaling for you automatically. As we have looked at a little bit of a demo app, if you want to have a look at that, I've got a link to the application source and you can deploy that for yourself and tweak it to do something different. A lot of people have made different versions of this app. I have the book. You can come out and see me for a copy of that. And you'll find these slides at cloudcraft.codemiller.com. Thank you very much.